Okie dokie, okie dokie. Hi, everybody. So we do have Mark on with us.
Hey guys.
As once again, he is much better at explaining stuff than I am. I'm just going to kind of mute in the background. But Mark, if you could, can you explain the difference between regular craters and complex craters? Had a couple people in the chat ask that question for you.
Yeah. I mean, obviously there's several kinds of craters. I mean, simple and complex. Now, a complex crater, something like we're seeing on the screen now as it passes by. I guess you'll see it in a few seconds or whatever. But if you look at that, that's a crater that has terraced walls and it has a central uplift. Okay. Now, a central uplift in the crater, all the morphology that we see of these craters depends on the actual gravitational force of the body. Okay.
Mm-hmm.
For instance, on Saturn's moon Mimas, there's a gigantic crater that's like literally like a fifth of the size, or a tenth, or well, sixth, or I can't remember the exact fraction. It's a massive crater on Mimas that's actually a good proportion of it. It makes it look like it's an eyeball, like a cyclops eyeball on Mimas. And if you notice, that thing actually has a central uplift in it. Now, that same crater on the moon would probably not be a complex crater because it wasn't as big an impact as some of the craters that hit the moon, or some of the meteorites that hit the moon. But a complex crater is very, from a certain point of view, here's the definition. Beyond a certain size, okay, and that'll vary, okay, the modification to the crater impact that occurs, all right, will either be simple or complex, or something in between. Complex will sometimes create these like ripples that you see, and they usually are a certain percentage of the distance away from the central peak in one of these craters. And so these craters are very interesting because they tell us a lot about the impactor. They tell us like what happened. They also give us an idea from studying them, gives us an idea of how they formed, the kind of energies that were released in making craters of this size. They're absolutely the most, I should say, the largest type of impact that can happen to the moon, short of splitting it, in half or something.
Right.
Because now the other thing that is important to understand, it kind of sort of goes hand in hand with this, is that we see complex craters on the front side of the moon, the side facing us, and then on the back side of the moon, we see a lot more craters. Did we talk about this before? I think you and I talked about it.
We did, but we have a couple of people that didn't catch that show. So, I mean, if you can go over it.
Yeah, I can do a brief. Not a big deal. Mm-hmm. See, the thing is that when we talk about the front side versus the back side of the moon, notice how the front side has all these maria, these darker gray areas. These are areas where lava overspread. And we've been puzzled by that. Planetary scientists have wondered for decades why the side nearest us has all this lava, and the side farther from us has just heavily cratered terrain with almost no maria. Now, the question is a good one, because you say, well, you would have to think, does it have something to do with the tidal locking? That is, the one side of the moon that's always facing us. Right. And there's been theories that say, well, because that side's been facing us, things that might have cratered the moon in the late bombardment era maybe hit us.
If I were to look at it objectively, just looking at the moon, saying and not knowing, I would have thought it had something to do with maybe the gravity of Earth pulling, say, hot, magma, if you will, more towards the Earth side. That would make it erupt, and actually level a whole bunch of areas out. But that's just me, of course.
Yeah, no, I understand. But in reality, when you look at the Earth-Moon system, okay, yeah, the moon is circling us, and it looks like it's really close here. But the fact is, the moon is 240,000 miles away.
Right.
And that's not close. So it's not close enough. It's close enough for certain things to happen. Because, for instance, in the early days, when the moon and the Earth were formed, there was an impactor, probably the size of Mars, the theory goes, that struck the Earth. And out of that resulting impact, the moon was formed. Now, maybe the Earth had a ring for a period of time, and both the Earth and the fledgling moon were all molten material at that point. Mm-hmm. So when that happened, that ring surrounding our planet finally kind of coalesced and became a moon that we see. And of course, the Earth and the Moon cleaned up a lot of the meteors left over, a lot of the junk and debris, asteroids that were surrounding both the Moon and the Earth at that point, because they were young. So that all happened, and then there was this era where the Moon became bombarded. Now, that time, which was like 3.8 billion years ago.
Is this the heavy bombardment area you were
Yeah,
talking
yeah,
about?
yeah. The bombardment era is actually, there were several phases to it. There was what we think is a late bombardment era, which is more recent, and then an early bombardment era. So think of it as two different bombardment eras. And if we look at the time when the late bombardment occurred, at that time the Earth was still very molten, very, very hot. Actually, molten. It was actually giving off a lot of infrared radiation. Now, the near side of the Moon was also very hot, and so, but it was, of course, in it's 240,000 miles away. It was closer to us at that point. Now, at that point, the side of the Moon that faced the Earth at that point, because tidal locking was rather immediate. It was almost certainly right from the start that it occurred. When that part of the Moon was facing us, it was subject to the infrared radiation that was coming off the Earth, which is a massive amount of infrared radiation. And so what would happen would be when impactors struck the Moon, they would splash, and they would make lava. They would be liquefied upon impact, and of course they would then go up into space, and the gravity of the Moon would slowly pull them back down. But the thing was that the process that allowed these things to cool and settle down on the Moon was actually something that was very complicated. It involved the Earth's radiative infrared energy. It involved the Moon's lesser gravity at the time. Okay, and what would happen was when these things hit on the Moon and basically exploded off into the space around the Moon, they would tend to be pushed to the far side of the Moon. So only there would the particles and the debris cool enough so that when they landed, they wouldn't be transported anymore. When they're on the near side of the Moon, they would be transported with the next impact and go up into space around the Moon, and then be pressed to the other side. Now, once that happened, the far side crust on the Moon, over billions of years, became thicker than the near side crust. So the Moon is actually lopsided. It's not really a perfectly even object.
Right.
It's actually very lopsided from center of mass point of view. So on the far side, where it was thicker, impactors had to go through far more crust to generate a magma flow, and they didn't very often, obviously, as we can see. But on the near side of the Moon, where the crust was a lot thinner, an impact would generate a lot of lava that would fill basins, fill craters. Plato's a flat bottom crater because it filled with lava.
And even on this side of the Moon, I mean, you can see a lot of what they're calling collapsed lava tubes. You can see them even on our view from what we see through Paul's telescope here.
That's correct. And one of the things about lava tubes is that they're near the surface. And so obviously the crust on the Moon is thinner on this side. So there's still some competing theories. This is relatively recent. There's still some competing theories as to why the crust on this side is thinner, but the mechanism seems to be that materials that would last a little bit longer as melted materials could actually, once airborne, ended up getting transported to the far side. And thus, when they got to the far side, they could cool or combine with other particles that would make them a little more massive, and they would tend to fall on the far side. Over time, that would make that crust thicker.
Right.
And that's, that we know is true, that the crust is thicker there. Now you would say, well, wait a minute. Shouldn't gravity operate on the heavier side and pull it toward us? So shouldn't the far side of the Moon be the one facing us, tidally locked? And the answer is that it could have gone either way, as a matter of fact. And because if it gets to that point where the balance is such that the Moon, which is going around the Earth, it has a moment of inertia. It has inertia, which is the resistance to being moved or rotated. And as it's going around the Earth, it would tend to have its forces the forces on it would tend to try and balance. And that balance could be that the far side would swing around toward us and be stuck facing us, or that the far side would stay balanced away from us. And that's still a little bit of a mystery that hasn't been solved yet.
Well, let me ask you.
Yeah.
We have a lot of people that ask this question as well, and once again, I'll let you explain it. But why do most of the craters look like direct impacts instead of, say, oblong? I mean, there are oblong craters, obviously, but for the bulk of them, they look like direct round impacts. Is that because of the way when they turn into, say, a liquid when they hit the moon, that the liquid automatically somehow forms into a round shape, or what's going on with that?
Well, that could be, but you also have to consider that it's also a question of perspective.
Right.
I'm not saying these are really oval craters, and that's not what I'm saying. What I'm saying is it's a question of perspective and distance. When you throw something horizontally on the Earth, okay, you shoot a gun at an angle slightly elevated. If you shoot it and it goes high enough into the air, when the projectile hits the ground, it's going to be falling straight down. And that's because of the fact that it loses enough energy, there's some wind resistance, etc., with the Earth anyway, and then it would then tend to fall straight down. So on the moon, we didn't have that. We don't have any air, but what we do have is gravity. And big objects, when they came toward the moon, would tend to curl toward the moon. And I've actually reproduced this on the simulator, where I could actually show, and it'll be one of our cloudy night Sky Tour live streams. You can actually show how objects cratering the moon over time would tend to fall down in a path that makes them hit straight down. And it has to do with the fact that these are objects that came from a very long distance away. When objects are thrown up by impact, they tend to make oblong craters, and we see them all over the moon. There's plenty of oblong craters that are usually smaller. They're called secondary impacts. All right, those are secondary and tertiary impacts and beyond. You have crater names that are, based on the same family of crater names, but they're the progenitor that is the one that started it all, was the big crater, and then all these little ones next to it, which were all the secondary impact craters. So you see that kind of thing. There's several craters on the moon that look like they skipped like stones on water.
Right.
They have these narrow pits that aren't collapsed lava tubes. They're actually a chain of craters from an object that's skidded across the top of the surface of the moon. So clearly, a lot has happened on the moon. Very different types of morphology are present there. And you look at the moon, even like in the shot here. We're seeing the moon here, and you can't find very many places that are not peppered with craters. In fact, if you go to the LROC Quick Map site, I mention this all the time because it's really phenomenal. Quick Map, LROC, the Lunar Reconnaissance Orbiter Camera, LROC. Look it up. You can zoom into the moon till you get up to a 0.5 meters per pixel setting, so you can actually see individual boulders that are half a meter across almost.
Yeah.
And when you do that, you can actually see that the craters just become more numerous the closer you get to the moon. There were billions of impacts on the moon over several billion years during this time. And there's still impacts going on, as we know, but far less than before. The impacts we've seen before obviously created what we see, but the impacts that are happening now are few and far between, and every now and then we catch them and we see what's going on, and I think it's pretty cool.
Do you have a favorite crater that you like to study on the moon?
Believe it or not, I do. And it's not like Tycho, and it's not Copernicus, right? I actually like Plato.
Oh, yeah?
I do. I like Plato's long, flat plane, basically. In fact, Plato was so large, it's 60 miles across. Plato was so large that it actually there's a curvature to it that you can actually see when you do a profile study of Plato. And Plato's always been a very interesting crater to me because it's in fact, I think we can see it in a little while. I thought he had it up before. when he was zoomed out. This is beautiful right here.
Clavius crater is just looking magnificent,
isn't it? Yeah.
Yeah, you still got to
Plato's
3D print that one for me.
Which one?
The Clavius crater. Oh, or was it out of the range for you?
Yeah, no, yeah. The 3D, yeah. For the models that I print from the moon, see, I can print models that look just like this.
Yeah, but didn't you say it had to be below the 60 degree or?
Yes, they have to be below plus 60 north and above minus 60 south.
And we never figured out whether this one was or not, or was it right on the line maybe?
Yeah, Clavius was actually too close to the line. I actually tried literally about less than a week ago to find Clavius because I knew you wanted it and I was going to try and print it out. And they have some certain craters that, people will just clamor for. So there is Tycho. I mean, we've got Tycho, okay, things like that. But, I'd rather just be able to, get the south polar view and grab, craters. I like Goclenius crater myself because it has those interesting lava tubes underneath the flat plane that's collapsed. Mm-hmm. Just really cool,
I've been studying a lot about the twins, Jackson and Tycho.
Okay.
It is amazing the dimensions of these two craters. How they are almost practically identical when you look at depth and width and two opposite sides of the moon. I'm baffled, like comparing them size wise, and I just wish we could see the backside of the moon. How cool would that be?
I think it'd be great. I mean, and as far as being the same, there's actually a lot more craters on the moon that I think are very similar to each other. It's just a matter of trying to find them because with that many impacts on the moon, it stands to reason you're going to find some that are almost identical in nature.
Yeah. Rock asked in the chat, let me see here. What is the strangest thing you ever seen on the moon with your own eyes?
Strangest thing you ever saw on the moon, huh?
I mean, was there an anomaly? Is there a weird spot that you were checking out on your own, say through a telescope or through any kind of imagery, or?
Oh, okay. Well, if we open it up to that, then I just have to go with some of the. There's one famous image that I thought, it was called the Shard.
Shard.
And it looked like to me it looked like an outgassing where, for some reason maybe a pit collapsed or whatever, and it sent a plume of smoke up straight in the air, and lunar folks that like conspiracy were saying, "Oh, that's an alien presence. It's a solid building. Look how big it is."
Of course, it has to be alien.
Yeah, it always has to be alien. But and I'm okay with that. I mean, it's sooner or later if we keep looking, we're going to find something like that, perhaps.
Absolutely, I have a problem with the people that jump to alien right off the bat.
Me too. We can't do that.
Yeah,
we can't do that.
I mean, you have to do your homework and make sure it's not something else first. What was it? Extraordinary claims require extraordinary evidence.
That's correct.
Yeah, but I don't like to jumping directly into. And one thing I wanted to get going with you, and maybe we'll do it at some future point or something. But I would love to do, say, a video like once or twice a week, with the UFO videos that like came out for the week. Because there's always seems to be one or two viral ones, semi-viral ones.
So you want to help them get more promotion? Is that what you're saying?
No, I want to take them and then dissect them and see if we can actually figure out what they are. Instead of jumping to the conclusion of, alien spacecraft or...
Well, keep in mind that, certain people that will remain nameless actually create CG spacecraft and UFOs weekly.
But you can detect that, can't you?
Yeah, I can tell. I typically can tell. Because I'm in that business, I actually have created CG spacecraft just for purposes of doing video stuff for television, movies, whatever. And
right.
I know for a fact that CG gives itself away, but it doesn't give itself away necessarily on a YouTube video that's been compressed.
Right.
you need the original, and sadly, they never make those available. They just
Well,
put
yeah,
them up, and now you're.
I'm not thinking about like going,
Hey, look,
grabbing
there's my favorite
clips,
crater.
grabbing clips from like say Secure Team or Third Phase or any of those guys. I'm talking about like, okay, we might see a clip from one of those guys, but then go to the original source and then dissect it from there. You know what I mean? Before they do whatever, And I'm sure there's a plenty, and I'm sure we can get people actually, if there is legit ones that people just want to send in to have us take a peek at. You know what I mean?
Yeah.
But I don't know how much time that would take up, and because I'm short on time as it is.
Yeah, same with me, and I'm not convinced that there'd be anything good to come out of that, other than it would just put the spotlight on them.
Oh, and it would also, define us as government shills, I guess.
Oh, I've been called that a million times already.
Yeah.
That I had a guy. This is so funny. Yeah, and a lot of people know that I've done classified work for the Navy. I mean, it's not a surprise. I did give up my clearance last year after having had it since 1994, and I did it only because I simply didn't make the deadlines for getting forms in, because I was actually recovering and so forth from my surgery. So I just let it go and said, all right, I'll just deal with not having government people walking through my house whenever they want to, and coming here whenever they want to make sure that I'm not a spy and all that stuff, and I'll give up signing my life away each year, saying I will not violate the Espionage Act under penalty of law, blah blah blah, and treason and all that. Yeah. I'll give that up. I mean, I certainly would never do that anyway. But I've actually okay. Hold on a sec. I was watching something on the screen here with the moon, and I literally forgot what I was just telling you about.
That's because it's birdie.
Yeah, it was. I was just like staring at this, and I'm just looking at this.
It's amazing, isn't it? And I was trying to explain to people earlier why it's so clear. Like when you literally, in order for us to have rain and stuff, it has to attach itself to dust molecules or dirt molecles,
which get ripped out of the air.
Right, and so when you have a storm, especially when it snows, like snow is like the greatest air cleaner like ever. Like if you get to go outside, like say after a blizzard or after a good 5-6 inch snowfall, where it's been snowing, for a good at least 6 hours, and you go outside right after that, after the clouds move out, it is the clearest stuff you will ever see, and that's because it took all them particulates, out. And even with where Paul is, where it's humid, you can actually still tell a big difference, even though it's still humid, of how clear the actual sky is of particulates and whatnot. It looks absolutely amazing.
Yeah.
Continue, sir.
That's good.
If you remember where you were.
Well, I was telling you, I said I was trying to get to a certain point, and I don't remember where I was. I mentioned how I gave up the clearance, and it had something to do with that. Shoot, I'm sorry, guys. I'm just like, I said I'm easily distracted. Oh, look, a squirrel. It's like, it's not that, but I am looking at the screen and looking at the features there and thinking, wow, it's just so beautiful. And then boom, thoughts leave my head as fast as they go in. I'll remember it later on.
You know what? And by the way, we need to have a chat. I'm gonna say I want to try to do it Sunday. I want to nail down everything. Are you still looking towards taking that thing down?
Yeah, I'm trying to figure out. The best way to get it down, at least to you.
Well, yeah, we'll talk about it on Sunday, because I'll actually have I'll be done and have everything scheduled with her down in Tennessee, and then we'll see what it looks like, and then we'll get it all scheduled up. But you definitely want to go down for the eclipse, though.
I do, because I've already got set up to stay in Knoxville for a couple days ahead of time. So after dropping the thing off in Knoxville, you'll continue on, and I'll stay in Knoxville for a few days, and then when are you going down?
I'm probably gonna leave. My guess, I'm probably gonna leave Friday afternoon sometime, because my goal is to get down there Friday night. And that way I can get like a good night's sleep and relax, and I can hang out with my friend I ain't seen in a long time.
18th.
Yeah, I don't have.
Okay.
Let me see here.
It's Friday the 18th.
Yeah, so I would leave Friday the 18th, and I'd be down there, and then we would meet up on Monday or Sunday night if you want to. It's up to you. And then we would meet up on the 21st, like in the morning, because I think I want to start streaming around 9 a.m.
Yeah, are we doing this from a skyscraper, or where are we doing this from? You mentioned.
Well, that's what I'm now. She's nailing down, but see, the problem with that is she had all that nailed down, but then we were thinking because so many people booked after that we're worried about bandwidth.
Oh.
From the hotel.
Gotcha.
So, and then we got to thinking, well, is it better just to do it from her house because she's got a clear sky,
Yeah.
And on top of that, we need to make sure
Nashville?
that we can get we need to make sure we can get mobile quick if we have to. So
Yeah.
can you imagine like taking the scopes? I mean, granted, they're just the solar scopes. Imagine taking them up to the top of the building and
And then the clouds rolling right in totality, and you're stuck.
Yeah, exactly. So we were thinking it might be better just to do it from her because she has great internet and.
Okay.
So
that sounds fair to me.
Once again,
okay
I will
that.
have all that nailed down as of Sunday, and then I'll Skype you Sunday afternoon sometime, and then we'll nail down our part. I know Bill said he wanted to go, but he wasn't sure about riding along and whatnot. So we'll find out about him.
He's still welcome to come with me. I mean, I don't have a problem with that.
Right.
I'll pick him up, or if he wants to actually drive here, leave his car here for the long weekend, and then I'll come back with him. He can do that.
Good. Yeah, it's definitely good. We're going to go down early too because, I mean, it's just traffic's going to be
It's going to be a nightmare,
especially around the cities.
It'll be a madhouse.
Yeah.
Is she outside of Nashville? Your friend?
Kinda. She's like in the burb of Nashville.
Okay, good. All right, so
it's not actually
probably
in town.
Okay, good. I think that's actually going to work out better.
Mm-hmm. I think so too. Yeah. So if we wanted to meet up on Sunday, we could go over there and just chill, and have everybody go out to dinner and whatnot, and then we'll take care of duty because Paul will be up there as well. So
okay,
and then we'll take care of duty on Monday and stream it. So
okay,
but anyway, we'll get all that down Sunday.
Yeah, that's cool. And what I could do is I could end up, I could see my folks on the late 18th and 19th, and part of the 20th. But then I go to where you are for the 21st, and we can do our thing. And then I don't know what you want to do after that. You want to do like a after eclipse party thing or something? I don't know what's going on.
Well, no, I'm actually heading back that night.
So, the 21st?
Yeah, the day of the eclipse. I'm actually probably going to start heading home around like 5 or 6.
Oh, okay, well that's fair because then I could actually go back to Knoxville and stay there another day with them. And head back the following morning.
There you go.
Yeah. I mean, it's not like I mean, I'm used to driving, and one of the things I don't want to do is make a first-time drive to Knoxville with a gigantic observatory dome on the back of a trailer.
Yeah.
And go through a toll booth and realize, it's not going to fit.
Right.
So I have to figure out what to do with this.
If you come down 81, I don't think there's any tolls on 81. It's just a lot of mountains. You'll use some gas if you're bringing your SUV, but...
Well, I'll probably bring my pickup truck.
Yeah, you'd have to bring the pickup truck. That's right.
Well, I don't have to. I mean, I could... If I could figure out a way to put it on there, and then, of course, I'll probably get pulled over because it'll be sticking out literally 2 feet on either side.
Well, you said how wide is that thing? 10 feet?
8.
8 foot. Well, your car's like, 6.5, 7 mirror span.
Well, if I can't lay down in a bed...
Well, that's all right. You just got to get some good crank straps. That's all.
Well, I actually bought a whole set, for that. I mean, but I just don't want to have it sticking out so far. And if I can avoid tolls, that'd be the best.
Well, yeah, I think 81 is your clearest shot. I mean, it's just, and you can hit that from New York and just be on 81 the entire time. You'd have a straight shot right down there. I believe so. Because that's the way we used to go up Central PA and whatnot.
Look at that. Paul's listening, isn't he?
I have no idea.
I said Play-Doh, and look at how beautiful he's got Play-Doh up on the screen right now.
Yeah.
Hopefully it'll be up there in 30 seconds. Yeah, that's beautiful.
Yeah, he's on it for a
See,
while.
that's my favorite crater. I mean, that's 60 miles across inside that crater.
And it's so weird how it has that little offshoot canyon, I should say.
I mean, the left?
Yeah.
See, that may have been a remnant of a previous crater, and when Plato was created, that's a rill that got pushed out.
Mm-hmm.
Maybe, who knows? That's what I love about this. You don't know all the details about how all this formed. And man, I would have loved to have been there during the time of impact. I wouldn't have had a home to go to, of course, because it wouldn't be made yet. But I would love to be able to look back in time and watch the bombardment of the moon.
Yeah.
Because we'd learned so much so much from watching this because sadly we don't have a we don't have a way to look back in time other than when we look at the starlight and so forth.
Do you think it's going to be private companies before anybody that actually puts a base there?
Oh, absolutely.
Yeah.
I really believe that. And I'll tell you why. Because private companies want to go there. Mm-hmm. And NASA doesn't. And
NASA has this attitude, kind of like been there, done that.
Their attitude is want to do it, don't have the money.
Yeah, very true.
Yep. Private companies say want to do it, have the money. Where do I go? Sign me up. I mean, they're ready to do it. Look at Elon Musk. Come on. It's not just Elon Musk. Okay, Richard Branson wants to make space a tourist attraction.
Yeah, Jeff Bezos from Amazon.
And Bezos,
Blue
right?
Yeah.
Right. Blue Origin. Exactly. I was gonna say that. Yeah, Blue Origin is another one. And you know what? The more the better because it's gonna drive down prices.
It will, but. Does that open up the moon for commercialization? Now, obviously, there's resources there. I mean, which is the main drive behind all of it.
Right.
Okay.
Companies have to make money if they go there, and
right.
I think that they should be able to make money because if you've got the wherewithal to put people on the moon for purposes of mining and refining, creating rare metals and rare earths, which are very rare on the moon. It's rare moons. Okay. Then I would suspect that you probably deserve the profit you make. And guess what? No one's going to know how much to pay for products mined on the moon. So they'll go at a premium for a while until they become ordinary. Same reason, like...
well, that's the only reason I think that, competition is good, because if you have one person up there mining the moon, they can pretty much set whatever price they want to. But if you have two or three, and even, I hate to say, even a government body up there like NASA, that's going to regulate the price and bring it down to a more competitive. Kind of like they do with gas stations, you know what I mean? You have two gas stations across the road from one another. They're each going to try to keep their price lower or rate at the other guys, That's
right. And I agree with that 100%. I think you're very prescient with that observation. I will say this, okay? You like that word, prescient? You can use it. It's free.
Thank you.
The thing I like here is that the countries are going to go to the moon for specific reasons, not to beat another country, because that's the been there, done that part of it. Okay, and I think that if we talk about where NASA is going to go, or the United States is going to go, we have to consider where China is going to go.
Yeah.
I mean, China didn't put a rover on the moon just because they wanted to learn science.
But one thing we have to make sure of as humanity is that, I mean, I know we have a bunch of treaties in place and whatnot, but we cannot put borders on the moon. You can't do it. It doesn't work here, let alone on the moon.
Yeah, and we didn't get that idea. I mean, we put flags at every single spot. But guess what? We don't own the moon. No one does. No one's claimed the moon, and no one will. Just like
we think.
Well, that's true.
Because, if you go up there and all of a sudden find a massive, let's just say, just out of the blue, okay? You go up there and China lands in one spot, and there is just a massive, like, billions of tons of gold for some reason.
Yep.
You think they're going to let the United States or the UK or anybody in that area? It's going to cause conflict here.
Do you think that they're going to even tell you it's there? No,
exactly. So that's what I mean.
That'll be a best kept secret for about 10 years, and someone will leak it. Then it could almost start wars.
So you think there should be some kind of authority over even the privatized companies that oversee them as a whole? Like, yes, you can go to the moon, and yes, but should there be something like the United Nations or something that oversees the entire thing?
Actually, I think that the United Nations would probably be involved. And I have actually very little use for the United Nations. Right. They become too politicized. Bending to whoever, does them the big...
Always found it fascinating. It's the United Nations, yet they're putting up more and more borders everywhere.
Exactly
so
right.
How united can you be, right?
Yeah. So, they should be called the Open World Foundation. That would be better,
Yeah.
But the bottom line here is that, when we look at the type of materials that we could get from the moon, that's not that's not a bad thing. I mean, mining the moon, the moon minerals and so forth that are on there. And by the way, I don't think we're going to find a whole lot of gold there.
Yeah,
to be honest.
I was just saying that as an example.
Yeah, because in the process of differentiation, when the moon cooled, it's smaller, but it could have been made. It could have had a heavier complement of elements, like when it blew out of the Earth originally. It certainly could have had a high gold ratio. For instance,
obviously, the most resource that most people are pointing to right now is the helium-3.
Yeah.
That's the one. But I just use gold as an example, for everybody to understand value-wise. Now, helium-3. Now looking at it, do you think helium-3 is more valuable than gold?
It depends what your target is. If your target is to go ahead.
If you're looking at scarcity, and the amount available, would you say that helium-3 is more scarce than gold?
I think that it's going to be more useful than gold.
Absolutely.
So therefore, it's going to be far more valuable than gold in the long run. Now, you can go up and hoard all the gold you want, all right? But you're not going to be able to convert it into cash until you come here. Because only here is where is there a gold standard. There isn't a gold standard on a moon colony, and there probably wouldn't be.
We barely have a gold standard here.
Yeah, well, that's true. We would actually have to think about how we're going to treat that. Now, interestingly, what you're suggesting right now is not quite in the purview of the Planetary Protection Officer role that NASA is currently seeking.
Which you should have went for, but didn't.
I still have time.
Well, do it. You're our inside guy. Go get the job and do it.
You want to know something? You literally, you were like the 28th person today to call me and say, okay, 28th person since the inception of the news blast that talked about this planetary PPO. Oh yeah,
you'd be perfect.
Perfect. Yeah, okay. Yeah, I want to create graphene.
That's my job.
I want. Hold on. You have to talk to the Planetary Protectorate.
I'll deal with the graphene. You can deal with the
that's fine.
Space paperwork.
Yeah, right. Exactly, and that's what that job will entail.
But you would be our in guy, you know what I mean?
An in guy having a lousy time. I mean,
very true. But I'm willing to sacrifice your happiness for this.
Yeah. Hey, guess what? Okay, someone who's doing that planetary protection officer job, okay, who do you think is going to get cut when the first complaints start rolling in about this, that, or the other thing?
Well, their main job is what? To make sure
that the PPO.
To make sure that we don't introduce any kind of stuff to another planet and
like Europa, right? They're in charge of making sure and overseeing all the mission parameters such that there will be no incursion into Europa that could leave.
So they should just call it a planetary contamination officer, pretty much.
That's exactly what. Yeah, planetary janitor.
Yeah.
Okay. It's a guy who's tasked with making sure that everything we send out there is clean and spick and span.
See, what they did is the
current one is a girl.
Yeah, and they split
the
the job
up. I'm figuring that. Yeah.
Into another job, and I actually heard that she might actually just go for that job to have two jobs. So it might not go to anybody. She just might continue with it.
Well, that's fair. I mean, or she could end up having an adjunct, I would be interested in it from one point of view, from the point of view of trying to figure out
paycheck.
No, actually, yeah, but 127,000 to start. That's that's not hay, I grant you. But look, look at Ted. If you breathe H3, you speak in squeaks. You mean helium-3? Yeah, yeah, right, exactly. Exactly so. Yeah. So yeah, I think that's funny, And part of my pausing and like sort of losing my train of thought is not only just the moon, like this gorgeous shot, but I'm also looking in chat and reading, and some of the things in there are really funny.
What's I know you have helium and then you have helium-3. Okay. Now, obviously, for chemists and everybody, we know that what the 3 stands for. But property-wise, besides the extra electron or whatever it is, trons, what can you do with helium-3 that you can't do with helium?
Well,
or helium-1 or 2. What's the major difference between those 4? You know what I mean?
Well, it's obviously a very light isotope of helium, of course. It has 2 protons, 1 neutron. Okay, so I think that its use is going to be more toward a fuel, using as a fuel than anything else. Now, it's also very important in fusion reactions, extremely important. Okay. And fusion is a potential and very likely energy source. And they always say, well, it's coming in 10 years, in 10 years. Well, yeah, they said that 30 years ago. Okay. But, until they learned just how difficult it was, then, that's when the predictions started saying, well, we'll get there when we get there.
Is their main problem containment of the reaction or
for fusion?
Yeah. Or is it?
Well, you gotta, yeah, fusion occurs at millions of degrees,
right?
And literally, for sustained fusion, we don't actually have any material on the Earth that can withstand that kind of heat.
Graphene.
You can't have a continuous fusion reaction going like that and have the container doing it and survive. The best part, though, is we will eventually figure out how to contain it and shield the energy from attacking the walls of the containment vessel or whatever. The nice thing is, though, fusion is not a destructive reaction. Fusion doesn't create deadly byproducts. The most deadly, to call it deadly, the most radioactive product of fusion is tritium. And tritium, you can rub tritium powder on your arm all day long and it won't even penetrate. So that's how weak it is. All right. In fact, you have tritium in your system right now. Yep. You probably breathed it in because that's the only way it gets into your body is by breathing it in. And it's also not cumulative. It will leave your tissues over time. So that's why fusion looks so good. A byproduct of water, good. And, using tritium from a breeder reactor, good. All right. Helium-3, good. All right. None of these, and helium-3 is not radioactive either. So this is a good thing. Right. So there's a lot of use for helium-3, both here on Earth and in space. And I think that when we look at where we're going to be going, especially with the fusion, you have to look at, and again, not everyone's a chemist. I realize that. Okay, there's several reactions that you can use to create fusion with helium-3, and fusion, by the way, is a great way for us to get energy, as you know, as I just said. It's not dangerous. When a fusion reactor is sent out of balance, it shuts off. When a fission reactor is sent out of balance, it melts down. Okay, and I've said this before possibly, but I liken and I'll tell you what that means. I liken a fission reactor to being a reaction going off in a deep valley. In order to make it stop, you got to push it all the way up the walls of the valley with great amounts of energy, and then you can get it out of the valley and then make it stop. What is that metaphor for? That's saying the control rods have to go down in between the fuel rods that are actually causing the reaction in a fission reactor.
By the way, check out those collapsed lava tubes on screen right now. And continue your talk by all means. I just wanted to point that out to you so you saw them.
Yeah. So the fission process, you have to put these inert rods down in between the control rods to stop them from reacting with each other. And to do that requires energy. Now, with fusion, it's the opposite. You have to imagine that your reaction is sitting on the tippity top of a very pointy mountain. The slightest imbalance, it's going to fall off. That is, shut off. Mm-hmm. And that's the worst thing that can happen with fusion. So fusion has to be held in balance.
Well, what's the difference between fusion and fission for people? in the chat.
Yeah, that's where I was going.
Okay.
When you talk about fusion, you're talking about taking, let's be simple, two hydrogen atoms and smashing them together under great energy and great temperature and pressure, and forming, in the end, a helium atom. All right?
Mm-hmm.
You can also do fusion reactions through helium-3, which I was just saying. Okay? But fission is different. In fission, the interaction between these highly radioactive particles in the fuel pellets that are inside a fission reactor cause radioactive particles to shoot out and come apart from those fuel pellets. When that happens, that generates great heat. And the whole point of a fission reactor, believe it or not, the only thing it does is boil water in the end to run a steam turbine.
Mm-hmm.
That's where we get the energy out of a fission reactor. And even if we do that in fusion, it'll be safe. I mean, I see the day when there'll be little fusion reactors the size of a Coca-Cola can that will take care of all your household needs.
Mm-hmm.
Everyone they'll have a fusion specialist who comes out like once a month to calibrate and keep it proper. And I think that's going to happen.
So this is pretty much being
That's
able to contain it is what is going to make, say, an orbital space station possible, or any kind of space station for that matter, because it'd be able to be powered.
Well, actually, a habitat on a Mars or a moon, or even a research station on a Europa or an Enceladus.
Well, the first thing that popped into my mind when you were talking about fusion and fission, believe it or not, was Mass Effect and the Citadel.
You
know what I mean? Because
I do.
The sign, because it did have the physicists and stuff work on the original game there, and somebody had asked him at one point why we didn't see solar panels on the outside, and he mentioned something about fission or fusion, and being that like every corridor had one, basically like you said, the size. Well, he said it was like a Pringles can size, but they were actually in the walls and whatnot, powering the entire place. And I was just like, so that's why when you're talking about that, that's what I got to thinking about space stations and whatnot.
Well, and don't forget, okay, we often find that science fiction becomes science fact.
Well, I think that's because we actually work towards science fiction to make it become fact. Like we actually, when science fiction comes out, we see it and we're like, that would be so cool to have, and then we work towards obtaining it. You know what I mean? Yeah,
and I take it a similar direction, a parallel direction, and I say, I don't believe that we can think of anything that's patently false, patently unable to be done.
Right.
I don't believe our brain can think of a truly impossible thing. Now,
but can a million brains?
Well, see, I think a million brains of the same architecture will be equally constrained.
Yeah, but if that was the case, wouldn't would we really be that far in technology where we're at?
I think so, because see, we're actually making strides that are commensurate with our technology. In other words, the strides we're making now are basically strides to be expected at this level of technology. I really do think that that's the case. So I'm not at all worried about our technology level at the moment. It's best if we go slow in the next 50 years.
We're not. We are so not.
Well,
look at the last 30 years and then compare that to the last 100 years before that, or 200-300 years. It's exploded.
No, but I mean in terms of developing things like the Alcubierre drive and
that'd be awesome.
Building a warp bubble, we really have to take our time with that, because the consequences of doing it wrong are that you can actually destroy your planet or your solar system with it. If you do it wrong, you can't basically, you know what it is? It's like using full strength sulfuric acid. Right. Okay, H2SO4 is a very powerful acid. In fact, if you ever see pure sulfuric acid, it's almost a syrup. Yeah. Okay, and I've played with it, and let me tell you, it's just the smell alone, you feel like your lung tissues are burning. Don't tell me when I smell it. Oh wait, I just did.
Sulfur smell, that beautiful sulfur smell.
Yeah, but yeah, that was actually the diatomic hydrogen H2, and then the SO4. That compound, you have to dilute it. And the one thing I remember I had to do all the time was dilute the pure acid because if you put it in it too powerful, it literally was unmanageable. And when in chemistry, when something becomes unmanageable, and I'm not a chemist per se, I just know chemistry based on the planetary science that I know. If you have a pure acid and you start messing around with it like that, as soon as you give it something to eat or something to corrode, it generates an awful lot of heat. And the purer the H2SO4, the purer the sulfuric acid, the higher the heat. You can literally cause a glass jar to break from the heat. And I actually, I remember when I actually created, as a kid, to tell you about the heat generated with these chemical reactions. I took sodium hydroxide, which is a strong base. That's sodium, Na, and then OH, an OH group. And I mixed it with hot water, and then I gave it something to chew on. I gave it metal shavings from a little factory next door, my parents' house. And I stuck it inside a glass bottle. That was a glass water jug bottle that you used to put in a water jug. The water coolers are now plastic, but it was glass. And I would cap it with a cork, but I had a little pipe coming out through the cork. It was a rubber stopper, sorry. And that would go to a milk jug filled with cotton. I'll tell you why. And then out of that, it went to another milk jug filled with cotton. And then a little tiny delicate tube out of that would go to a little tiny lightweight clothing bag.
Oh, I can imagine your parents. Oh.
No,
Mark's down there making meth again.
No, it wasn't that. I was actually, you had to do it outside because the bottle got so hot that I couldn't touch it.
Yeah.
And what I was making was hydrogen.
Yeah. And
I actually was leaching hydrogen from the reaction of the sodium hydroxide with the water and the metal shavings, which are the catalyst for everything. And I got hydrogen as a result. The cotton in the milk jugs was actually just a moisture trap to catch the water vapor that would also come out from steam.
Right.
And I ended up having these hydrogen balloons, and it took about 4 hours to fill one clothing bag with hydrogen. And then I'd have this extremely lightweight balloon. And, of course, I did what anyone does when you fill a bag with hydrogen. I immediately take it into the empty lot next to my house, tether it off, and shoot it with a flaming arrow. And the resulting explosion would knock me right on my ass, and I would laugh hysterically and then run because they would always call the police. Oh, yeah. I mean, you always knew when I was outside
days,
playing.
You'd be arrested for terrorism or something like that.
Oh, yeah, I know.
Around.
Yeah. But I actually, I sat there and, I'd lay on my back with sand and all over my face and dust that was, from the shockwave that's flying around. And I'm sitting there going, wow, that one was the best ever. But it was literally like you saw this bright orange flash, and then you felt like getting punched in the chest with like somebody swinging a 4x4 post at your chest.
Nice shockwave thump.
Oh, it was beautiful.
Yeah.
And
just for people in the chat, there is no lenses or filters used. By the way, somebody had asked.
None?
Nope.
Oh, okay.
Direct cam.
Wow, looks nice.
It's beautiful down there tonight, which is why we're not giving up.
Yeah, I see a little chromatic aberration there. I see the color shifts at the edge of the craters where the edges are sharp.
Yep, and I can actually, I might be able to take that out on my end actually, but I like to leave it a little bit brighter.
Well, I mean, if you made a grayscale image, you would, but you don't have to.
Yeah.
And then it's not real.
Yeah, like I can take it. You'll see it pop up on screen, grayscale and whatnot. It's just not the same.
No, it's not. And you always know it's grayscale.
Yep.
The moon actually has a color.
Yeah, it's
like
that's bluish, greenish.
Well, green cheese? Oh no, don't say that. No, but people think the moon's just gray. Actually, it's not. It's actually it's a sort of a brown tinge. Mm-hmm. The lunar soil is sort of brownish, and the gray just happens to be the way photography works. When you look at the moon with a telescope, and you look at the moon, very clearly. Oh, I see the gray level. Yeah, that's clearly a gray level. Yeah, when you look at the moon, it actually does have sort of a brownish tinge to it.
Which is what I try to represent coming through here. Like the image. Once again, it depends on what you're watching. Because I have an Alienware computer right next to me, and this is coming off more gray on this one because I think I have a cooler.
What's the monitor?
Yeah. So, but on my main screens here, it has a more grayish brownish kind of tinge to it.
Mm-hmm.
You know, could try to give it a little more real color to it. You know what I mean?
Yeah.
But it doesn't show up all the time on different monitors and whatnot. So.
Hey, Soundly's asking you if you can tell him how you're all wired up.
No.
So we can.
It would take way too long. So this is all wired up. I want to do the same thing with my 8-inch scope for my kids. Soundly, all you got to do is, this is what you need. You need your scope. You need a camera for your scope, whether it's through a DSLR attachment. If you do it that way, you're going to need a focal reducer. And then you need a capture card, say like a Elgato capture card or a
Blackmagic,
Blackmagic capture card that captures that. And basically what you're going to do is you're just going to feed that camera into the capture card. The capture card will actually send it to your computer where you can live view it and then stream it if you want to.
Or you can just go HDMI out of your camera at the telescope and go live into your television.
Yep.
You won't be able to capture it, but you can actually see it.
Yeah, so you can literally like go from your camera, if you're just doing it for you and your kids, you can literally go straight from your camera into like a big 60-inch screen TV if you want to, and so you guys can see what's going on the big screen. Like everybody can see it once without having to look through an eyepiece and everything. You can do it that way if you're not talking about wanting to stream or anything. If you just want your kids and everything to see it.
And you can tell them if you're looking at the moon, you can say it's just a close-up of Edward James Olmos' face.
Right. And if I were even to attempt to tell you how me and Paul are all set up between the two, I would be here for hours.
Well, right off the bat, he's in Miami and you're in Pennsylvania.
Yeah.
So this makes a big difference right off the bat. You've got there's obviously some there's a bridge there that connects the two of you guys through a fairly large pipe for you to be doing this.
It's called an ISDN.
Yeah. Oh yeah, but it's an ISDN line.
Close enough.
More like a T3, it should be.
Yeah. But yeah, so, that's how you do it, Sally. I mean, you can just do it as simple as that. And actually, I want to get more guys streaming. You have Charles in the chat that does moon videos all the time. He's been talking about streaming. Just there's a whole bunch of people, and it's almost like they're studied because they don't know how to stream, but they do know how to do the video. And I think the main piece that a lot of the guys are missing is the capture card. You know, a lot of guys think you can just feed like, your camera and an HDMI out to a monitor, but that monitor is not giving you a way to connect it to the internet and say to put it on YouTube.
Right.
And with a capture card, that's all done for you.
And you actually left out one important piece, and that was the broadcast software that you have to get
to
be able to send this out.
Because there's so many.
It is, but you also have a lot of parameters to care about.
True.
And you gotta if you learn about bit stream, the bit rate and stuff like that.
Go back and look at me and Paul streams for like a year or two ago. I mean, you'll see you won't see hardly any of this on the screen. It was just kind of like what did people like? Did they like the clock? Did they not? And sometimes I had it on, sometimes I had it off. We didn't have the P&K logo back then like we do now. But just putting all this stuff on the screen, we finally got it to where. I was just doing votes in the chat, like, do you guys like the clock, not like the clock, should I move this, should I move that, we finally got to what you're seeing today, and I still move stuff around a little bit, especially, like, when I got to post about clouds and stuff, and the only reason I actually post about clouds is for the people that come in when we've been streaming for an hour or two already, and go, why am I looking at a black screen, without even thinking for a second. That's why I usually have to put the cloud thing up. That you all have seen before. It usually says, clouds are in the area or whatnot. So,
right. But I do see the astroimaginglive.com notice down there at the bottom right.
Yep, Astro Imaging Live. And actually, Bill had fixed my live link. So actually, if you go on astroimaginglive.com right now, you will actually see this feed. It's there live.
That's fantastic.
And once again, I got to give a shout out, of course, Mark, to your channel. You've been streaming and doing just that night. That one was a couple nights ago, I believe it was.
Yeah.
Just the imaging you were getting just blew my mind.
Oh, it's beautiful. It was a beautiful night.
You were even getting
I was getting giddy. Yeah, I admit it.
I don't blame you one bit for how clear it was that night.
Yeah.
And just the stuff that you were able to get was just, it was blowing my mind. And
then, it was beautiful.
Of course, now you have Bill, and with the Perseids meteor shower, you had Bill streaming for the last 4 or 5 nights in a row. Now, he's not doing it tonight just because he has to get up early tomorrow, but I do believe he'll be streaming again tomorrow night The Perseids, I think, peak is on the 12th, if I'm not mistaken. And he's capturing meteors. Because last night and the night before, you kind of had a dual meteor shower going with the beginning of the Perseids, and then you had, I don't know what the other one was. But he was capturing them. Beautiful meteor showers, high definition, just amazing stuff. So, once again, that's all three of us are on Astro Imaging Live. You have Bill, New York Skywatcher, if you want to check that out. If any of the mods want to link him in the chat, of course, Mark D'Antonio, you got the Sky Tour live stream, and of course, us here at P&K. Doing planetary bodies and the moon and sometimes some solar stuff.
Yep. And
we will be doing the solar eclipse on August 21st live from around Nashville, Tennessee.
Yeah, that's right.
So.
Oh yeah.
Yeah, good stuff.
I'll bring my solar. I'll bring my little personal solar, my PST as well.
There you go. And I did. You know what? I did carry your stream for about 20 minutes or a half hour the other night. I don't know if I told you or not. Yeah. I think I told Amanda. Yeah, I think I told Amanda to tell you that I was going to carry it just so some people would head over your way.
That's good. It was fantastic, man.
Yeah, I mean that night was just crazy. I mean,
yeah.
And you put them? Did you put them up to download those pictures? I know you put them up, but I didn't know if they were the full size files or not. If they were.
Yeah, I did put up several full size, and I notated in the. On the Sky Tour live stream companion site in Facebook, I notated it by saying, "Try your hand," to show people they could actually download this image in it. And I didn't put up the RAW file because that's a lot bigger.
Right.
But I did say that if you want the RAWs, contact me and I'll make them available to you.
I want the RAWs.
You can have the RAWs.
Yeah.
You can have the RAWs. You can have the RAWs.
Dude, that one I am totally getting sent off and printed out on
Which one?
Canvas. Shoot, I can't open the window right now, but it's the one.
Was it the M8, the Lagoon?
No. It was shoot, I can't. My brain ain't working right
Trifid M20.
If I could open up Facebook, I'd be able to say right away what it is, but I can't because I got so many freaking screens going. Let me see if I can get it on this one.
Well, you just tell me which one it is, and I'll send you what I have for it. Because I have my camera. When it captures a RAW and it captures a JPEG. So I need the JPEG just so I have a thumbnail to see, because my PC doesn't read the RAW native, but it reads the JPEG RAW, of course.
I'm loved it.
But we'll get it.
Loved it. And anybody that didn't see it, you can jump on. If you have a Facebook account, you can jump on Sky Tour live stream at Mark D'Antonio on Facebook and check out the photos. Amazing night the other day.
Yeah, I actually saw there's a very low surface brightness, typical problem in astronomy, a low surface brightness nebula. It's actually a supernova remnant.
That's what it was. That's the picture. You're right.
In Cygnus, and it was the Veil supernova remnant. And I have never seen it in my life.
It looked like a wayward firework trail. You know what I mean? The way it was.
Oh, yeah.
You know, just crazy amazing.
That might be the one near 52 Cygni there, the one where there's a bright star at the bottom and it's got this little tiny filamentary needle starting to go up there, and that was just beautiful. We get more nights like that, and of course from Arizona, something like that would be very, very easily achievable.
The pictures that you posted, or did you work those images? Did you stack them at all, or was that just what naturally came out of the camera?
I put up images that were stacked and then images that were raw, so you could actually just, not raw but unprocessed, so you could see the difference. And the stacked images it's like all the fainter details come forward when you stack. So I actually made sure that I stacked minimally 8 to 10 photos of the things I wanted to show better, and that's pitifully few.
Yeah, with that remnant one, I would love to have the stacked image of that in the highest quality I can, so I can get that thing printed.
Okay. Certainly.
When you get a chance.
Okay. Well, I will certainly set that aside for you. Not a problem. Yep. I just gotta know which one it is. That's all. You gotta tell me which one you saw. Cause I have two. I have two remnant images up there.
Yeah, because Paul was actually watching that night too, and he was just blown away as well about just the amount of detail you were getting with that. You know.
Yeah. Well, the other thing too is I think the telescope is in need of collimating. So, I was going to collimate it tonight, but we had vicious thunderstorms and possibly even a tornado that roared through here earlier.
Oh, wow.
Yeah, and I looked outside because I thought the dome was certainly going to be sailing off the observatory. But it stayed. It was perfect. And I went out there because I thought for sure I was going to have water that got inside, and it was fine. None of the water got inside. Everything was good.
Awesome.
Yeah,
do you want to explain the mare real quick on the moon?
Yeah, I mean, sure. I mean, obviously, Maria are areas that are overfilling formerly cratered terrain. Like when you look at this section of the moon, you can actually see how there's craters that are filled with lava, and that was from the impact on this side of the moon, the near side. Mm-hmm. The far side, as we said, doesn't have any Maria per se, and the reason has to do with what we talked about earlier, but with that the way the cooling process and the way that the moon's crust was formed over time, with the far side being thicker than the near side. So the near side, quote unquote, bled easier when it was hit. It was much easier to get an impact that could draw blood, basically, or lava. So the Maria that you're seeing here on the screen, these are areas that are overfilling craters that have long since been filled in. You'll never, ever know what was under there unless we can go out down there with some type of ground-penetrating radar or some such thing, or do a study like that from orbit, and possibly learn a little bit about what's below the Maria. Maybe you're going to be interested to note that there's probably just as many craters on this side as the far side. Mm-hmm. Okay, but that most of them on this side are filled in. That's what I think is interesting. So it's lava that overspread the area from impacts, and because the moon is thin-skinned on this side of the moon, the lava could be brought up quicker and easier, because these all happened when the moon was still fairly molten inside. It was still very hot inside. It's still you could get molten lava out of the interior.
And we're talking about a high percentage that happened during that time frame. Would you even go 98%?
98% for what? What are you saying?
For the time frame of where most of these craters happened. Would you say 98% of them happened around the same time? Being a billion years?
Yeah, I know. Yeah. If across the span of a billion years is not a big deal. Well, it was a few million years of bombardment. Mm-hmm. And you know what? Like I said, I'd love to have been there to see it, because I can't imagine. Like when you look here, just imagine watching Copernicus get made. I mean, when Copernicus crater was made initially, there was this gigantic ejecta pattern thrown out from it. Now, it doesn't just go out and splash and it's over. It would have taken many hours for that crater impact to settle down and to occur. So we would have found that when say Copernicus was gouged out, that you would have just seen this large blanket of just ejecta coming up and away. Much of it would have left the moon, but some of it would have gone back to the moon. So when stuff like that is ejected from the moon and leaves with an escape velocity that can allow it to get away from the moon, then that promotes some mass loss, to the whole moon as a whole. But the moon actually has some, even though it's 1/6 of the Earth's gravity, it's a pretty substantial enough gravity so that most of the ejecta from most of the impacts that you see here came back to the moon and hit on the moon. So, but I think it's just a fascinating thing. Just look at the complexity of these scenes. Look at the complexity of the mountains and the what they call the highlands, okay, and the Maria. And you can actually see, if you imagine that as water, you can see how those Maria are hiding other features below, like craters that are flat bottomed. Well, they're flat bottomed because lava overfilled, the interior of the gouged pit, basically created by the meteor. The meteor itself, when they hit, you got to remember they're hitting at many kilometers per second, and so they're vaporized on impact. And what's vaporized mean? It means that the heat is high enough that it melts them and they get vaporized at that point.
Let me ask you.
energy is huge. The energy release is huge.
Yeah, yeah. It's do you think what we know about the moon right now?
Yeah.
Do you think there's a way, and I'm not saying anytime soon, I'm not saying like 2020, I'm talking about in the next 1,000, 2,000 years. Do you think it's possible to terraform the moon?
Well,
Being
to
what we know
terraform,
about it.
well, knowing what we know about the moon, the only way to terraform something like the moon is if you could have the moon have an atmosphere, for one thing. But the other thing you need to terraform a planet is a magnetic field.
Mm-hmm.
And the moon doesn't have a magnetic field. You have to have a magnetic field in order to deflect high energy solar particles.
Well, we are talking
Otherwise,
about a
you would
thousand,
have to
two
depend on
thousand.
your.
But what creates a
Oh,
magnetic field? You're talking about a molten core, correct?
yeah. I mean, the dynamo. Well, not a molten core. Usually, the core is solid, and
Mm.
the outer core is the molten part.
Okay.
See, it's a little. It's a mental. It's a mental mind screw because, you know, under that much pressure, the core is going to be solid, but the outer core is a lot more molten and more able to run molten. So that molten core running over the solid core is what generates the electric current, which generates the magnetic field. And while a planet is still hot, while a planet is still viable, it's going to have a molten outer core, a molten uh, situation in the interior, so that you can generate a magnetic field. Earth is pretty much, of the rocky planets, Earth has the best magnetic field.
Mm.
Mars has some remnants of a magnetic field on its surface. We know it had a magnetic field because some of the crystal structure on Mars reflects the magnetic field it used to have. But
Venus?
Venus, what's funny? Venus doesn't have a magnetic field per se. It doesn't have one that works the same way as the Earth. But it does have a magnetic field effect. And it's not the same as the Earth, otherwise Venus would be a very different looking place. Venus has an atmosphere that's 90 times denser than ours. And the reason it's 90 times denser is because, like Earth, which also had a 90 times denser atmosphere at one point, Venus had a lot of water vapor in the atmosphere, had a lot of that. Earth and Venus were sister planets at one point
Mm-hmm.
in the early solar system. But then once it started to, say, rain on the Earth, rain could condense and fall out of the sky because the temperature cooled enough. Venus was just inside the edge of the habitable zone at the front, at the close end. So it couldn't actually cool down enough to allow rain to happen. Because it never rained on Venus, then it never made oceans. The oceans serve as a carbon sink, meaning they absorb and dissolve carbon dioxide like no tomorrow. And the dissolved carbon dioxide would go down the bottom of the oceans and combine with other elements down there, forming things like compounds like calcium carbonate, for instance, and limestones. But the thing is, on Venus that didn't happen. On Earth it did. And when it didn't rain on Venus, Venus never benefited from the reduction of its atmosphere by a sink that was the ocean that could have pulled the extra carbon dioxide out of the atmosphere. That happened on Earth. And when that happened, it paved the way, actually, for those little cyanobacteria. And this was like 3 billion years ago when they first showed up. And those little buggers are basically oxygen generators, and they like to eat carbon dioxide. So they filled a niche where they had to clean the rest of the atmosphere. And then, of course, life in the oceans started, and plankton were formed. And there's I don't know if you saw my Facebook post today, but I talked about the plankton in the oceans, which actually is literally responsible for half of the oxygen generation on the planet.
Mm-hmm.
And we have these little plankton guys. There's like millions of them in a drop of water, ocean water, and they generate all the oxygen. And they also, keep oxygen overabundant on the Earth. Now, for a planet like Mars, we had no such thing as an ocean there in the long run because the Martian climate was such, and just on the outside of the habitable zone, outer edge, the Martian climate was such that it was kind of too cold, and as such, the atmosphere couldn't stay thick enough, and much of the atmosphere ended up being lost to space because the ultraviolet radiation hitting the cloud tops was able to disassociate H2O molecules, water molecules in the upper atmosphere, separate them into hydrogen and oxygen, basically, allow the oxygen to bind with chemical, with the elements on the ground, and the hydrogen would escape to space. Well, when it combined with elements on the ground, what did it combine with? It combined with the iron compounds. And what do you get when you put oxygen with iron?
Yep.
Rust, iron oxide.
Yep.
And what color is Mars? Mars is red because of iron oxide. So, you see, these things all make sense when you put them together, and I think that's pretty cool when you look at them in those terms. So I think that, terraforming the moon, I don't think that could work. But if we say terraforming to a degree, we could create a subterranean cave system on the moon. We could create a atmosphere for inside an enclosure, which could be generated by processing and refinement of elements on the moon. And we could also get water from the permanent dark side or permanently dark craters that there are on the moon. So there is a way that we can terraform to a degree, but I don't think we'll ever be walking across Plato and going for a hike across Plato crater, or things like that.
Right.
Let's go to Archimedes today. Let's take my car. I mean, it's not going to be quite that way.
Well, they are making massive leaps ahead in spacesuits these days. Where most likely the next people to go to the moon aren't going to have those bulky, bright white spacesuits you've seen before, but they're more or less going to be skin tight, that actually regulate temperature and whatnot. But before we jump on that, we did have a question from chat that I wanted from Jeff in chat. It's about optics.
Yeah.
And he says, on a reflector scope, how come we don't see the obstruction from the secondary mirror? And he said Google was not his friend.
Well, in the same way, you don't see it on a Schmidt-Cassegrain telescope either, unless you go out of focus. When you take the image out of focus, you will see the secondary mirror. So it's not it's not that you don't see it. It's just that you don't see it when it's not when it's in focus.
There you go. Beautiful. So yeah, so hopefully we answered you guys' questions about the whatever questions you had about the craters. I think the guy that did initially ask that has left by now.
Yeah, probably.
He might still be around somewhere, but yeah. So yeah, once again, thanks for coming on, buddy.
Sure.
And,
sure, no worries.
Once again, we'll get our whole plan of action together for the 21st.
Okay.
So, I think you actually been on for about an hour, Mark.
Oh, not a half hour?
Yeah, I think.
Oh.
You know how time flies. That's just how.
Yeah, I know. I actually thought it was 30 minutes.
Yeah. Yeah.
No worries.
But yeah, I'll let you go off of the Skype, and then are you going to hang around in the chat in case anybody has any more questions or anything for a little bit?
No, I'll probably be around.
That'll work. Give your voice a rest. Do you have anything coming up you want to promote? Any radio shows or anything?
I do. August 12th, I'm doing two things. I'm doing a presentation in Indiana for a group out there. And that'll be a Skype conference. And then later that evening, I'm doing a talk. Again, this is thanks to Amanda, in Japan, with a group in Japan.
Nice.
Yeah, and that'll be morning their time, which is 8 p.m. my time.
Is it kind of like what we're doing with David Schmidt for his class coming up this year?
I think so. And yeah. I haven't heard anything from Dave. I don't know if he's around, but I haven't heard what's happening with that.
We've been communicating by email. We were going to do it by the end of the last school year, and then time kind of ran out on us.
Yeah.
And we had kind of crappy weather there in June, so we were talking about doing it again this fall at some point.
Yeah. Yeah. But then in September 15, 16, 17, I'll be out at Devil's Tower in Wyoming. I have to do. It's 3 day conference, and I'm actually speaking all 3 days. So I have 3 different lectures.
Are you going to stream at least one of them? Maybe.
I want to, but it depends on the internet.
Did you need a roadie?
Well, we are going to be out in the middle of nowhere, so I'm not even sure we're going to have internet.
Yeah.
So, but I do. I mean, at the very least, I'd like to record it. If they're not going to, but I hope they are.
Awesome.
Yeah.
So that's your two one. You said when was that, the 3-day one taking place?
That's September 15, 16, 17. It's called the Devil's Tower UFO Rendezvous.
Nice.
And you may remember Devil's Tower as being the featured monolithic landmark in Close Encounters of the Third Kind.
Right.
Yeah.
Can I make an admission right now that a lot of people are going to hate me for?
Yeah, you've been to Devil's Tower.
No, I have never seen that movie.
I hate you.
I know.
No,
I've seen a lot of them, and I was like, and everybody keeps telling me about this, and I look for it on Netflix, and it wasn't there, and then I was like,
no, it's not gonna be on Netflix. Yeah.
Yeah, so I was like, but I plan on seeing it. Don't get me wrong. I just never have seen it myself.
It's a Spielberg movie, you know. I mean,
no,
it was pretty good.
I saw one that was like the fourth kind.
Yeah. Okay.
And that was more like one that happened in Alaska or something like that. But
yeah, I remember that.
Yeah, I definitely got to see the third kind one. And then once again, I got to throw in, of course, Astro Imaging Live, where you have P&K, myself and Paul, and Mark with SkyTour Livestream, and Bill New York Skywatcher, all streaming from there. And I can almost guarantee there's going to be a time in the next 5 days where all 3 are going to be streaming.
We were the other day.
Yep, if the weather pattern holds up. I think we have all of our links fixed now, where everybody, once we go live, it automatically pops on. I think we're all fixed. I know I am. I'm not. Didn't you have a problem with it too?
Yeah, I don't think I'm fixed yet.
All right, so we still got to fix you up, but most likely.
Yeah.
And then what we'll do is, if it does come down to a night like that, we'll. I'm actually gonna jump the chat over to Astro Imaging Live, and do the chat from there. So
cool.
I might close down this chat and just kind of leave a link to the Astro Imaging Live channel, so everybody can get over there and get their names and.
That's a good idea.
Before they're taken.
Yeah, right.
Because they give you the weirdest names in that chat. Like when you first, like if you're just an anonymous person. I think my name was like Snugglefart the first time I signed up for it or something like that. It was just really weird. So you definitely want to.
I think I was rotting eggplant or something like that.
Yeah, it's crazy. Well, Mark, I definitely want to thank you again. Once again, Mark, FX Models. Of
Thanks,
course,
man.
the MUFON video analysis, photo analysis.
Yeah.
I think he's half a robot, probably.
Not yet, but
astronomer.
Yep. I'm not like is it what's the name of the robot woman in People of Earth?
Shoot, I forget.
Wendy or Wanda or something like that.
Yeah.
Yeah.
Amazing.
Oh, hey, Amanda, thank you. Amanda just posted the Astro Imaging Live link in there. Thank you.
And there you go. And as you can see, we are kind of getting hazy on the screen a little bit. We're going to stick with it until Paul wants to wrap up. So, I mean, I'm just going to go ahead and let it play. But once again, Mark, thanks for joining me, bud, and answering questions. I figured you could do it a lot better than I could. That way I didn't have to type it out, too. So that helps.
I think you hold your own pretty well sometimes, huh?
Yeah, sometimes. Do you have any plans for this weekend when it comes to, besides streaming, if it's clear?
Well, I'm a slave to streaming now, but let's see what's happening this weekend. You know what? MUFON, the Connecticut chapter of MUFON, is having a picnic on Saturday, and they have a rain date for Sunday. And I'll be going to that. I think it goes from like 11 to 3 or noon to 3 or something like that. It's on a lake in Farmington, Connecticut. It's very nice. Okay. So check out their site if you're in the area, you want to come by. That'd be great.
Boy, you're just up to all kinds of stuff, aren't you?
Not enough.
And I will say, we will try to get Amy Title on this Saturday night, being that
still
it's
haven't
clear.
had her on.
I do. We were going to do it last weekend, and then she ended up having something to do. We're still in constant contact on the email, but yeah, we're gonna try. We're gonna try for Saturday night again. I'm looking at the forecast for Miami. It's looking pretty good. So
Okay.
we should be able to get her in and learn a thing or two about the Apollo missions, because this
Nice.
lady
She's-
knows her stuff when it comes to Apollo.
Yeah, she's the right one to ask about that.
Mm-hmm.
We all have our knowledge bases of the moon landings, but then there's someone who just basically lives, eats, and sleeps with moon rocks, and that's probably probably be someone you want to talk to more than someone like me who wouldn't have as much information about that.
Yeah,
She'd be great.
I'm talking from launch to landing and back. She'll be able to tell you and answer any questions you want to see, or you want to know the answers to. Just amazing wealth of knowledge when it comes to the Apollo missions and space in general. So it's going to be neat to have her on. And once again, we'll shoot for that for Saturday night. So
Okay.
yeah, Mark, I'll talk to you once we go off air here. But yeah, just thanks again, bud, for coming on. And once again,
sure.
you're welcome anytime. And I definitely got to get over and chill in yours sometime. Every time I want to, I end up doing something.
Yeah, well, you came on for about 4 minutes the other night,
No, I was there for like
And you said-
20 minutes.
and then you said, "Well, Amanda."
Well,
knows,
here's
'cause
the
she-"
thing. Here's the thing. I don't want to
And you
interrupt
said, "I'm going to
your
go
flow.
eat." You said, "I'm going to go eat."
Well,
and
no,
then,
I had somebody here.
Oh,
So
okay.
I didn't, I was kind of like doing both, but especially when I'm over on your channel, I don't want to interrupt your flow.
Oh, yeah, I don't
because
mind
when
that
you
though.
start
You're able to
taking-
do that.
Yeah, I mean, I'm pretty good at interruptions, but I'm
It's
just saying
okay.
because not only am I there to chit chat, but I'm also there to learn myself. So I do, I like listening myself, and kind of I get lost in it when I'm listening, and I'm kind of like, oh, there's really no need for me to be on here unless I have a question or whatnot. So, but yeah, we'll get over there. We'll do it. We'll do it one of these nights. I mean, I'm not sure what I personally can offer to your stream, but we'll try.
There was a night when you came on, and you were asking what I considered extremely intelligent questions about the things we were looking at and the concepts we were discussing. So, believe me, I think that you have plenty to offer. You don't sell yourself short on that, man.
I think what I need to do is I need to know what you're streaming before you actually stream it, so I can be like, okay, let me learn a little bit about this, and then if I have any questions, I can do them, and it would actually play into the context of what you're streaming. So.
Yeah, no, I actually think Amanda just gave you up. She said you chose Game of Thrones over the stream.
Yeah, I did.
See? Okay, thank you, Amanda. Thank you very, very much.
I mean, it's Game of Thrones, man.
I know.
All right,
you gotta
Mark.
find out if what happens to Cersei or the Mother of Dragons.
Yep.
I mean,
That's what we got to do.
yeah.
But once again, we'll continue the live stream here. Everybody say goodbye to Mark. And
Good night, folks.
If you have to, go over and get on the Facebook so you know when he's streaming. Go over to his channel and subscribe and click the bell so you'll get it. The same for this channel here if you want to know when we come on. Because once again, all of us are at the mercy of Mother Nature. So the clicking that bell
Yeah.
and the subscribe button is the best way
Yep.
to know when any of us are streaming.
Yep.
All right. So Mark, thank you once again, and we'll talk to you in a little bit.
Okay, and let me just say one last thing.
Sure.
I just want to say, Amanda's here in the chat. I just want to thank her publicly for all the work she does for the Skytour live stream. She actually helps me hold it all together. She's very good with that. And so having her on board when I do my stream is very, very good because I can't see the screen where the chat is when I have my screen with the imagery coming up. And I'm doing like 5 things at once
Bird alert.
all the time.
Bird alert, just so anybody that sees
Oh,
that going
bird.
across the screen, you'll see a bird. It's not a UFO.
Yeah, okay.
Yeah, Amanda does a great job, and I've had her on here,
Yeah.
especially on times when I've had you on, and she does a fine job. And I think we both are going to owe her a nice little Christmas card come the end of the year.
You're only getting her a card? Cheapskate.
Hey, it'll be one of those ones that sings or something. I don't know.
Wow, that UFO looked like a bird. But I'm bummed. Yeah.
All right.
Cool.
All right, big fella.
Hey, man.
Yep.
Hey,
We'll talk
thanks.
to you later. Yep. Have a good
All
one.
right, guys. Good night, folks.
Later.